Hey everyone, welcome to Chapter 4, Section 6, Isosceles and Equilateral Triangles. Here we're going to be solving problems using properties of isosceles and equilateral triangles. So up at the top here I have the properties of isosceles triangles. You already know that isosceles triangles have two congruent sides, and so those sides are going to be called the legs of your isosceles triangle. So look at this picture, leg, leg. The third side is going to be called the base. And the base is going to be the side opposite of the angle at the top. That's going to be called your vertex angle. So here we have our legs of our isosceles triangle, right? So these are the congruent sides of the triangle, and where they meet is called the vertex angle, okay? And so opposite of that angle is the base. And so anytime somebody says opposite of an angle, you do it a lot when you're talking about trig, but we're not there yet. We'll get to it. It's a later chapter in our textbook. But the side that's opposite of angle 1 is the base. So you should be able to draw a line that points to the side that's opposite of it. That's really what it means. It may sound obvious. It may sound confusing. I don't know. So I just want to be clear. Like the side that's opposite of angle 2 is that leg that I'm pointing to right there, and the side that's opposite of angle 3 is this leg right there. So these angles right here at the bottom, these are going to be called your base angles because you can think of it because they are adjacent to the base, they're touching the base, they're not the vertex angle. The base angles are going to be congruent because if an isosceles triangle has two legs that are congruent, then it's going to have two angles that are congruent. And those angles will be opposite of those legs, what I was just talking about. So these are called your base angles. This is called your vertex angle. These are some theorems that were in the book. They pretty much just say what I just told you, that if two sides of a triangle are congruent, then the angles opposite of those sides are congruent. So base angle 1 and base angle 2 are congruent to one another because they are opposite of side AC and side AB are congruent sides. And then this is the converse of that. If two angles of a triangle are congruent, then the sides opposite of those angles are congruent. So the side opposite of angle D would be FE. That's going to be congruent to ED or DE because that's opposite of angle 2, which is marked as congruent to angle 1. So yeah. So in example 1 here, I'm going to point out the two unmarked congruent angles and the two unmarked congruent segments. So to point out the two unmarked congruent angles, I'm going to look at the triangle that doesn't have any marked angles. So the angles will be opposite of the congruent sides. So this side is opposite to B. And then you know it's opposite because you won't be able to it won't curve. Like if I want to get it to point to angle A, I'd have to kind of like get it to curve a little bit. Or angle C, I'd have to get it to curve. So those aren't going to be opposite of this side. You should be able to draw a straight line to it to know what's opposite of it. So angle B here is my congruent angle, and so I will mark it like this. So that's angle ABC. And then this side is opposite of angle C, and so I will call that angle ACB, and I'll mark it there. So next I'm going to point out two unmarked congruent segments. So I'm going to look at the triangle with the angles marked and not the segments marked. I guess technically the segments marked, but so this angle, so angles D and C are marked as congruent, right? So that means the sides opposite of them will be congruent. So side AC is opposite of angle D, and side AD is opposite of angle C. So yeah, that's what I'll say for this answer. So I hope that made sense about what's opposite of the angles and such, what sides are opposite of which. If you got any questions, of course, you could leave a comment in the comment section. And then the next thing to point out is properties of equilateral triangles. This one says that a triangle is equilateral if and only if it's equiangular. And so if a triangle is equiangular, all the angles are going to measure 60 degrees because the sum of all the degrees in the triangle is 180 degrees. So do 180 divided by 3, you get 60. So anytime you have an equilateral triangle, you have 60 degrees. That doesn't help you figure out what the side lengths are. The side lengths will vary, but the angle measures will always be 60, no matter if you have a big equilateral triangle or a small equilateral triangle. So in this example, I'm either going to have an isosceles or an equilateral triangle. I'll figure out which one is which based off of my angle measures and or the side lengths. So I'm going to try and figure out as much as I possibly can. So here I have 3 inches given here, and it's marked as congruent with this. So I might as well mark this as 3 inches there. And so I don't know 100% for sure whether this is 3 inches or not yet, but what I can tell you is that 2x is opposite of 3 inches, and 2x is the same exact measure as this other 2x. So this side opposite of that 2x has to be the same thing. So therefore, this does actually equal 3. So now I'm 100% sure that this is going to equal 3 inches. So the first thing I'll do right now is I'll solve this for y. I'll do 4y minus 5 equals 3. So just add 5 over. 3 plus 5 is 8. What's 4y equal to 8? So divide both sides by 2. 8 divided by 4 gives me 2. And then you can always, check your work if you want. Plug 2 in. 4 times 2 is 8. 8 minus 5 is 3. So it works out. So if all sides are 3, then you know right off the bat that it's an equilateral triangle. So knowing that kind of helps you figure out what your x is. If it's equilateral, then I know each angle is going to be 60 degrees. And I can also kind of prove it to you that way with this. So if 2x here was opposite of a 3, and this 2x here is opposite of a 3, then this is going to be another 2x because it's opposite of a 3. So I'll put 2x degrees right there. And so if they're all the same degree measure, you know they're going to equal 60. So you got 2 different ways of solving this. So I'll do them both. I can do them both in time. So you know they're going to equal 60. So just say 2x equals 60. If you divide both sides by 2, you get x equals 30. Well, let's say that's not coming to you for whatever reason. Well, I know that I've been able to figure out that these are all 2x's. And I know that all the angles in a triangle add up to 180 degrees. So I have 3 angles that measure 2x degrees, and they add up to 180 degrees. So if you do 3 times 2x, that's 6x equals 180. And if you divide both sides by 6, 180 divided by 6 is 30. So either way, you're going to get 30. And then you're going to know for sure that your angles measure 60 because when you plug it back in, what's 2 times 30? Because it said 2x degrees. So 2 times 30 would be 60 degrees. So then if I was trying to determine what kind of triangle this was, is it equilateral or isosceles? If it's neither of those, then it'd be scalene because scalene has all different sides. But this one's definitely an equilateral triangle because all the sides were the same and all the angles measured to 60 degrees. So here I have a similar example. I'm going to find the same type of answers, find out exactly, I'm going to try and find out every side length and every angle measure if I can. So like looking at the side lengths here, I see that this is congruent with this, and I don't know anything about that third side. If this is 80, then that means I don't have an equilateral triangle. So that means I'm going to have a third side that's different. And so basically we don't know exactly what this side's going to be without doing some sort of trigonometry. But like I said, we'll get to trigonometry later on in the year. Right now we're only on chapter 4, so it comes in a later chapter. So all I'm trying to say is don't worry about trying to figure out this missing side, but I can figure out this missing angle, and then by extension I can figure out this missing angle because I know all the angles add up to 180 degrees, whereas the sides, they can be whatever they want. So if you really don't know what will be there, what should be there, then don't worry about it. But we can figure out what these two sides are. they're marked as congruent, so set them equal to each other. 4y minus 2 equals 2y plus 2. When I had these two-sided equations with a number like a constant and a y on both sides, I like to do it in one step. So you need to get your y's to one side, so minus 2y over, and that will clear the y's out on the right-hand side. So I cancel one thing on the right-hand side, so I'll cancel one thing on the left-hand side. I'll move my constants over, and I'll move it all over to the right side. So yeah, I canceled one thing on each side. So bring everything down. 4y minus 2y is 2y. 2 plus 2 is 4. Divide both sides by 2. And you can see that y equals 2. So I do not know what my side length is until I plug it back in. It doesn't matter which one you plug it into because you set them equal to each other. So you should get the same thing. So 4y minus 2 is 4 times 2 minus 2. That's 8 minus 2. That's 6. See, so if you plugged it into the other one, that's a 2 times 2 plus 2. 2 times 2 is 4. 4 plus 2 is 6. So both these sides equal 6 units long. Okay? Now that we have our sides figured out, we can figure out our angles. And the most common mistake I see kids make is they see an angle and they set like a side length equal to it. I'll never take 2y plus 2 and equal it to something that's inside the triangle here, because they're pretty much independent of one another. Sure, they're kind of related in a way. You're like, oh, if these two sides are congruent, then I know that the angles opposite of them are congruent. But that's about all they tell you. You're not gonna take the numbers on the outside of a triangle and set them equal to the numbers on the inside of the triangle, because the ones on the inside are angle measures, the ones on the outside are side lengths. Okay, so back to this about the angles. What I pointed out just now is important to know, that I have 80 degrees up here. That's going to be my vertex angle. If I have two congruent sides, then I have two congruent base angles. So I have two angles that measure 6x plus 8 degrees. So you can figure this out one of two ways. Since we know that this is 6x plus 8 degrees, and this is 6x plus 8 degrees, and this is 80, you can add all these up and equal it to 180. So I have two sides of 6x plus 8, and then I have 80 degrees, and equal it to 180. And so you can solve this a couple different ways. Most kids, they'll probably do this. They'll want a minus 80, which is correct, minus 80 to the other side, and then they'll want to distribute the 2. You could also divide out this 2 to the other side, yeah, I just distribute. So that's going to give me 12x plus 16, and then 180 minus 80 is 100. So I got a minus 16 to the other side. 100 minus 16 is 84. So if 12x equals 84, then divide both sides by 7. Not 7, by 12. The answer is 7. Sorry, I was getting ahead of myself. And so yeah, x equals 7. And so if I want to figure out what the degree measure is, plug it in. 6 times 7 plus 8. That's going to be 42. 42 plus 8 is 50. So they're each 50 degrees, which makes sense because 50 plus 50 is 100, plus 80 is 180. So the other way you could have figured this out is, since you can tell that this is an isosceles triangle now, because you have two sides marked as congruent, and you know this angle here is not 60, then you can deduce that, hey, this isn't an equilateral triangle, and because two of the sides are the same, it's not scalene, so it's got to be isosceles. So that means take this away from 180, that's going to give you 100, and then these two angles have to add up to 100 degrees. And you know they're going to be congruent, so just cut it in half. This one's got to be 50, this one's got to be 50, which is what we got when we plugged it back in. So the other way of doing it would be to take 6x plus 8 and set it equal to 50. And so if you just minus 8 over, you get 42. And then 42 divided by 6 is going to get you 7. And so, with that, I figured out that my angle measure is 50, and I figured out that my x is 7. So either way you want to approach it is fine, as long as you end up with the same conclusion. But yeah, that's going to wrap it up for my video. Thank you for watching. Hit that like and subscribe button if you want, and goodbye.